Section 4.3 is about right angle trigonometry. So what we're going to do today is we're going to understand how the six trig functions relate to a right triangle. We're going to evaluate sines, cosines, and tangents for special angles. And we're also going to solve a trig function for the sine, or given the sine, cosine, or tangent. So we've got a right triangle down below with an acute angle labeled as theta. That's down here in the bottom left corner. And then the six trig functions are related to it as follows. Now, a couple of reminders. So if that's our angle measure, the hypotenuse of the right triangle is always the longest side. The adjacent side is the leg, not one of the two sides, the two shorter sides, that's touching that angle we're talking about. And then the opposite side is the side that it's not touching. So the sine, if you think back to when we first learned about it, SOHCAHTOA. The sine is SOH, the sine of our angle. OH stands for opposite over hypotenuse. The cosine, CAH, so cosine of angle theta, is the adjacent over the hypotenuse. And then the tangent of our angle is opposite over adjacent, OA. Now the other trig functions, the reciprocals, we talked about those a little bit last time. We got the cosecant of theta, secant of theta, and cotangent of theta. Cosecant is going to be the reciprocal of sine, so that's going to be hypotenuse over opposite. Secant is going to be the reciprocal of cosine, so that's hypotenuse over adjacent. And then cotangent is the reciprocal of tangent, so it's adjacent over opposite. So for the bottom one, we're going to use this triangle down here, come up with the six trig values. We have a 3 as one leg, a 4 as another, and we don't have the length of the hypotenuse. Now we have that good old Pythagorean theorem, a squared plus b squared equals c squared. If you want to get fancy with it, you'd say the sum of the squares of the two legs is equal to the sum of the, or is equal to the square of the hypotenuse. I said you want to sound smart, then I stumbled through it. Whatever. The two legs, doesn't matter which leg you're going to call which. I usually call the horizontal leg A and the vertical leg B. So it's going to be 3 squared plus 4 squared equals whatever c is squared. 3 squared is 9. So we got 9 plus 16 equals c squared. Well, 9 plus 16 is 25 equals c squared. And to solve for c, we're going to take the square root of both sides. And we're going to say, oops, sorry, I scrolled too far. And we're going to get c equals 5. Now I'm going to pause here because normally we would say it's plus or minus 5. But since we're talking about distance, we're only going to focus on the positive version. So c is 5. So the sine of whatever that angle is in the bottom the bottom left corner. The opposite side is the side that it's not touching. The adjacent side, well, that's convenient that I called adjacent side A. So the side opposite is that B side, so it's 4 over the hypotenuse of 5. Cosine is the adjacent side, in this case 3 divided by hypotenuse of 5. The tangent is the opposite over adjacent, so it's going to be the 4 divided by 3. Now cosecant is the reciprocal of, sorry, I'm waiting for air server to catch up. There we go. The cosecant is the reciprocal of sine, so that's going to be 5 over 4. Secant is the reciprocal of cosine, so that's 5 over 3. And cotangent is the reciprocal of tangent, so that's going to be 3 over 4.